Okay, let's look at a gas law problem next. Determine the volume of H2S gas at 375 degrees K and 1.2 atmospheres to produce 55 grams of sulfur gas. Assume that there is an excess of the other SO2 reactant. Alright, so I can see I'm probably going to have to use, since I have a volume here, and I've been given some temperature and a pressure, that I'm going to have to use my universal gas law. So just so we remember what that is exactly. So that's going to be pressure times volume equals the number of moles times the universal gas constant times the temperature. Volume has to be in liters, pressure has to be in atmospheres, temperature has to be in degrees Kelvin. Alright, so first thing we can do is we're going to have to use stoichiometry to get to the number of moles, and then we're going to have to use moles to get to volume. So let me start here. I have 55 grams of sulfur. Okay, I have to know the molar mass of sulfur, so I know that there are 32 grams of sulfur in 1 mole of sulfur. Now that I'm in moles, I can do my stoichiometry. I know that for every 3 moles of sulfur that are produced, I consume 2 moles of H2S. And so I write that down. I have 3 moles of sulfur are going to be produced when I consume 2 moles of H2S. My grams of sulfur are going to cancel out. My moles of sulfur are also going to cancel out, leaving me with moles of H2S. Okay, and then what I can do is I can take those moles and just plug it here into my gas law. So let me go ahead and get that answer here. So again, I start out, it's 55 divided by 32 times 3 divided by 2. Okay, so this is going to give me, is going to be equal to 2.578 moles. And from my sig figs, I know there's going to be 3 sig figs, so I'm just going to go ahead and underline it so I remember that when I plug that into my equation. So I'm asking for a volume, so I'm just going to rewrite that universal gas law, that the volume equals mRT divided by the pressure. So volume equals N. Here's my N. I just calculated that using the stoichiometry. 2.578 times R, which is 0.08206, times the temperature. I gave that in the problem as 375 degrees K, divided by the pressure, which is 1.20 atmospheres. So now I can do that math. So I had 2.578 times 0.08206 times 375 divided by 1.20, and that is going to give me then 66.1 liters. So a lot of liters there. 66.1 liters of H2S that I'm going to need. So again, these gas problems are actually not, I don't think, terribly hard to do. There's going to be 2 ways that you're going to do it. You're going to have to use the stoichiometry here to get to the number of moles, and then take that number of moles, plug it into your universal gas law that we have here. That's one way. Sometimes, though, you're going to have to use the universal gas law to get the number of moles, and then use the moles to get to your to do your stoichiometry. So 2 ways to go. These are doable. The only little wrinkle we do now is we use the universal gas law to manipulate our number of moles.